Okay, so a school guidance counselor examines the number of extracurricular activities that students do in their grade point average. The guidance counselor says the evidence indicates that the correlation between the number of extracurricular activities a student participates in and his or her grade point average is close to zero, so zero correlation. A correct interpretation of this statement would be, all right, so is it going to be A? A says active students tend to be students with poor grades, and vice versa being students who have very little extracurricular activities going on tend to have very high grades. Okay, so A is going to be false because in order for A to be true, we would have to have a negative correlation. As your extracurricular activity goes up, your grades go down. But we've been told that our correlation is close to zero, so that's why A is false. B is going to be false for the exact same thing. It says students with good grades tend to be students who are not involved in many extracurricular activities. So this is just another example of a negative correlation, but what we have is a zero correlation. Now C is going to be part right, part wrong. It says that students involved in many extracurricular activities are just as likely to get good grades as bad grades. That's the incorrect part. It says the same is true for students involved in few extracurricular activities. All right, so the grain of truth in C is that students involved in many extracurricular activities are no more likely to get good grades than students who are involved in few extracurricular activities. All right, so when you have a zero correlation, that means that students who have a lot of extracurricular activity going on are no more likely to make good grades than those who have very few. They're also no more likely to make bad grades than students involved in few extracurricular activities. So that's what a zero correlation would state. But this part about students being just as likely to get good grades as bad grades, that does not follow from a zero correlation. So in fact, imagine a high school where pretty much every single student fails. Every single student is failing, both those who have a lot of extracurricular activities and those that have very few extracurricular activities. All right, you have a zero correlation there. You have a zero correlation, but clearly they're not just as likely to get good grades as bad grades. They are much more likely to get bad grades than good grades. In fact, they are all getting bad grades. Right, so if that was confusing, rewind this, listen to it again. Let me know if you still have questions about that point. All right, but due to process of elimination, we're going to see that it's definitely going to be D that is the right answer. There is no linear relationship between the number of activities and grade point average for students at this school. And this adjective linear is important. Let's talk about that. Because there could be a relationship between number of activities and grade point average, but it not be linear, and you still would then have a zero correlation. So I'm going to show how that can happen. So first, what is a linear relationship? A linear relationship is any kind of relationship that can be described by basically a straight line. That's where that word linear comes from the word line. So here, if this was the relationship between GPA and hours of extracurricular activities, right, as your hours of extracurricular increase, so does the average GPA for students as a whole. All right, that would be and that can be described by this line right here. That would be a positive linear relationship. All right, I can give you guys kind of the sketch to go along with this. So here we have a student with 5 hours of extracurricular activity and a GPA, an average GPA of 2. We have another student who has even fewer extracurricular activity hours, but an average GPA of a little bit over 3. All right. So in this case, the one who had fewer extracurricular activities had the higher GPA when we're just looking at these two cases. But when we look at all of the students as a whole, we can see that those who have more hours of extracurricular tend to have a higher average GPA, and it can be pretty decently described by just this line right here. All right, so in that case, we would have a positive linear relationship. All right, we can also have a negative linear relationship. Now here's the trick question. A linear relationship here. And I mean, we have a line. We can see that this line would fit perhaps data that looks like. All right, I'm forgetting that I get paused whenever I transition from slide to slide, so I apologize if some of my words have been lost. We can see that this line kind of describes the data here, but remember that there is no trend to this data. All right. In other words, your hours of extracurricular activity basically has like nothing to do with your average GPA. All right, some people have few, very little extracurricular activities, have low grades, some have normal grades, some have high grades, and the same with those who have a lot of extracurricular activity. You get some with low grades, some with moderate grades, some with high grades. So there's no relationship between our hours of extracurriculars and our average GPA here. So even though this data is best described by this flat line, if you have a flat line, what that indicates is that there is no relationship. So this is why this is actually what's being described in our problem. All right, we have a flat line, no linear relationship when we look at the data. Those that have few hours of extracurricular activity are no more likely to make high grades than those who have a lot of extracurricular activity going on. I want to contrast this with a non-linear relationship. All right, so here we have a relationship, but it's non-linear. We can see that those that have very few hours tend to have a low GPA. Those with a lot of hours also tend to have a low GPA, but those with a moderate amount of hours tend to have a very high GPA. All right, and we can't really fit this well with a straight line, but with a curved line. All right, let me say that again. We can fit it with a curved line. So because we can't fit it with a straight line, this relationship isn't linear. And so, in fact, if we tried to fit this with a straight line, let's see what that straight line would look like. All right, that straight line would be flat. So we can see that there clearly is a relationship between hours of extracurricular activity and your average GPA here, but that relationship isn't linear. And so if you were to try and calculate a correlation, you would get a correlation of around 0 in this case. Correlation really only tells you if there's a linear relationship. Okay, so all that is just to say that the correct answer is D. There is no linear relationship between the number of activities and grade point average for students at this school. And to put that in context, those who have a lot of extracurricular activities are no more likely to make high grades than those who have very little extracurricular activity. All right, let's look at problem number 11. It says a survey was designed to study how business operations vary according to their size. Companies were classified as small, medium, or large. Questionnaires were sent to 200 randomly selected businesses of each size. Because not all questionnaires were returned, researchers decided to investigate the relationship between the response rate and the size of the business. The data are given in the two-way table. So we have two variables, all right, whether they responded and the size of the business. And the first question asks us which variable should be used as the explanatory variable, and obviously which one's going to be used as the response variable. Now remember, the explanatory variable is the one that's having the effect on the other variable, and the other variable, the response variable that is the one that's being affected by the explanatory variable. All right, so let's talk about why whether or not they responded cannot be the explanatory variable. What that would mean, let's first take a look at this. All right, they sent out 200 questionnaires to small businesses, to a medium-sized business, and to large businesses. All right, so they sent out the same amount to small, medium, and large. Now we can see just by looking at it that the large businesses had the lowest response rate. They tended to not hand back the questionnaires. All right, they had a very low response rate compared to the medium-sized businesses and the small businesses. So we can tell that it's the large ones that aren't responding very much. Now we know that the response rate can't be the explanatory variable, because what that would imply is that if your business decides to not respond to any of these questionnaires, then that would make your business large. Just by choosing to not respond, that's going to make your business large. Obviously, that makes no sense. No, so what likely happens is that something about being a large business makes you less likely to respond to these questionnaires. Right? Your business size has an effect on whether or not you respond to the questionnaire. So that's why business size is going to be your explanatory variable. Okay, let's look at the second part of this question, part B. We're asked to construct a segmented bar chart to summarize the relationship between business size and whether or not the business replied to the survey. All right, so remember that whenever we're making a segmented bar chart, we have to convert these numbers, which are just count data or frequency, into percentages, proportions, relative frequencies. Remember, these are all the same thing. All right, and so what's going to be the proportion of small businesses that did respond to the questionnaire? Well, that's going to be 125 divided by 200, or 0.63 when rounding. All right, what about what proportion of medium-sized businesses did not respond to the questionnaire? That's going to be 119 divided by 200, or 0.59. Remember, 0.59 is the exact same thing as 59%, and 0.63 is the exact same thing as 63%. So we can go about doing this for the rest of these boxes. When you do so, you should get the following. And now that we have these, we can construct our segmented bar chart. So I've gone ahead and made that. All right, so the blue bars is the percent that did respond. So we said that 0.63 of small businesses did respond to the questionnaire, so that blue bar is going to go up to 0.63. For medium-sized businesses, 0.41 did respond, so this blue bar for medium-sized businesses goes up to about 0.41. Now, what about this number right here, 0.37? All right, so we're going to add another 0.37 to what we already have at the small businesses. So we're at 0.63 here, and we're going to add another 0.37 worth of an orange bar. Now 0.37 plus 0.63 will just add up to 1, or 100%. All right, and remember that these segmented bars in a segmented bar chart always ultimately add up to 1 or up to 100%. So that's why all these go up to the same height. All right, now when we look at this, we can see that there clearly is an association between the size of the business and whether or not they responded to the questionnaire. There's always an association if one of these segmented bars looks very different from one of the other segmented bars. And we can see that each of these three segmented bars look different from each other. For example, the small business segmented bar has a lot more blue in it and a lot less orange in it than do the other two segmented bars. So that means whenever these segmented bars don't all look identical, and these three segmented bars do not all look identical. So whenever you have that, you know there's an association between the two variables. And it's pretty clear here how we could describe that association. Smaller businesses tend to have a greater likelihood of responding to questionnaires. Larger businesses have a lesser likelihood of responding to questionnaires.